Let's practice our vocabulary for algebraic expressions together. For number 1, we have 4x plus 18 plus x plus 5. And right off the bat, we'd like to have plus signs or have the whole thing written as a sum. So we do have a plus sign, and a plus sign between each of these terms. Now, what are terms? Well, terms, again, are defined as pieces of an expression that are separated by plus signs. So if that's true, then we have a term over here of 4x. We also have a term of 18. We have a term of x, and we have a term of 5. Now, there are 4 terms here. Now, the other thing that we want to make sure we understand is that we have an invisible 1 in front of this x right over here. So every variable must have a number in front of it. So what are the terms here? All the terms are going to be 4x because we have plus signs. We have a positive 18. We have a positive 1x. And then we have a positive 5. So these are all the terms for this expression. You can just use a comma to separate them. Now, out of these 4 terms, which ones are like each other, right? Now, anything that has the same variable and the same exponent can go together here. So if we take a look, we can see here that we have 4x and 1x. They both have x's. So we can go ahead and say that of those like terms, we can say 4x and 1x. Those are called like terms. They're like each other. And next, you can either use a semicolon or a big slash. I'm going to use a big slash so we can make it very clear what's like each other. So the 4x and 1x are like each other. And we also have what else after that? So we also have to the right, let's go ahead and use this orange for 18 and 5. So 18 and 5 don't have the variable x, so those are like terms with each other. So it's just 18 and 5. Okay, so these two are like terms. They both have an x, so we write them as terms that are like each other. And then we have this 18 and 5. Those are like terms, so these ones are like each other. Next, we have coefficients. So coefficients are just numbers that multiply by a variable. So if we take a look at this 4 in the 4x and this 1 in the 1x, those are our coefficients. So we have a 4 and we have a 1. Those are our coefficients. Okay. Next, we have these things called constant terms. And so for constant terms, those are just going to be our numbers that are just regular numbers, right? So we have 18 over here and 5. Those are our constant terms. Those we can write as 18 and 5. Okay, so constants are just terms that don't change. They constantly stay the same. Okay. Finally, for our simplified expression, this is where we can actually combine our like terms together. So if we take a look at our like terms over here, we have 4x and 1x. That's a positive 4x and positive 1x. 4x plus 1x, that is going to be a total of 5x. So we can go ahead and add their coefficients together, and we're going to get 5x. And then we can go ahead and take a look at this 18 and 5. Those are like each other. So 18 plus 5 is going to be 23. So we're going to go ahead and write, we have a positive 23. So we can go ahead and write that just like this. Okay, so we had an original algebraic expression that looked like this. There were 4 terms to begin with, but our simplified expression over here only has 2 terms, right? And you can see here that we combine the ones that were like each other. So 4x and 1x combined to make 5x. And then this 18 and 5 combined to make 23, or positive 23. All right, here is number 2. For number 2, it looks like we have this expression of 3x plus 9 plus 8x plus 2. Again, we like having everything be written as a sum, so we have plus signs. So by definition, our terms are separated by plus signs. So we have 3x, positive 9, positive 8x, and positive 2. So our terms here, we can just write those down. 3x, positive 9, just use a comma to separate them. 8x and positive 2. Now, which one of these terms are like each other? Well, we can see here that we have this 3x. Does anything else have an x? Well, this 8x does, so we can say that 3x and 8x are like terms with each other. Again, I'm going to use this big slash to separate. You can use a semicolon too. And then what else do we have that are like each other? Well, it looks like we have this positive 9 and positive 2. So we can say 9 and 2 are like each other as well. What about coefficients? Well, coefficients are just the numbers that multiply by the variables. So coefficients here, we have our 3 and we have 8. Right? Those are the numbers that are separating them. And then for constants, well, constant terms are just numbers that are by themselves. They constantly stay the same. They don't change their value because they don't have a variable. So we have 9 and 2. Okay, so those are our constant terms right over there. And then what about our simplified expression? This is where we combine some things together. So this 3x and 8x that are like each other, 3 plus 8, we add their coefficients. That's going to be 11. So we can say this is going to be 11x. And then we can go ahead and add their 9 and 2. These constant terms are also like terms. So 9 plus 2 is 11. So we can just write plus 11. Okay, so we started off with 4 terms in the beginning, but because 2 of them were like each other, we can say that we have only 2 terms in our simplified expression. So this is the same, would give us the same value as what the original one has. All right, for number 3, this one's a little bit different, right? We have this algebraic expression of negative 5x, but we have minus 7, then plus 9, then plus 18x. So can you spot the difference here? We do like this plus sign over here, we do like this plus sign over here, but this minus sign is a little bit of a challenge or a problem for us here because it's not an addition sign. So terms are defined as being separated by plus signs, right? Well, no worries, we know hopefully how to take a subtraction problem and rewrite it as an addition problem. So we can keep this negative 5x, because subtracting 7 is the same thing as adding its opposite. We can add a negative 7 instead, and then the rest of this stays the same. We have plus 9 and then plus 18x. Okay, so if you just go ahead and add the opposite or keep change and then flip to the opposite value, then we can go ahead and say, oh, we can have an all addition problem all the way across here. Okay, so now that we have plus signs all the way across, what are our terms? We have 1, 2, 3, and 4 terms. Our first term here we said we underlined was negative 5x to begin with. Now it's not a 7, but be careful, it's a negative 7, right? Because we keep changing flips. So as an addition problem or a sum, it's a negative 7, and that's how we have to define our terms as. Then we have a 9 here, and then we have an 18x. So be careful with that minus sign. Now, which ones are like each other? This negative 5x and positive 18x, they're like each other. So let's make sure we keep the negative 5x, but positive 18x, those are like terms. And what else are like each other? Well, we have a negative 7 and a positive 9. So negative 7 and positive 9. So those are like terms. For coefficients, those are the numbers that are multiplying by the variables. So this negative 5 is a coefficient and this 18 is a coefficient. Okay. For our constant terms, those are numbers that just don't change in value. Negative 7 and 9 stay the same. They have no variables attached to them. So we can say our constants here are going to be negative 7 and 9. And then for our simplified expression, if we go ahead and combine these two, we can add their coefficients. So negative 5 plus 18, that's going to be positive 13. So this will be 13x when you combine those two together. And then you can combine these like terms, negative 7 plus 9, that's going to be a positive 2. So we can go ahead and write plus 2. This would be our simplified expression. Here's number 4. For number 4, we have this expression of negative 5. Let me move up a little bit here to get some space. We have negative 5 minus x plus 7 plus 8x. So we like this plus sign here and this plus sign here. Our problem that we have to deal with is this minus, so we have to go ahead and change that. Also, don't forget that there's technically a 1 in front of this x because every variable has a number stuck right next to it that's multiplying. Okay, let's rewrite this thing. So we have negative 5 and it's subtracting, instead of subtracting 1x, we can go ahead and add a negative 1x, right? Because adding the opposite is going to be the same thing. So negative 5 plus negative 1x, this plus 7 is fine, leave it alone, and plus 8x is fine, so leave that alone. Okay, so do we have all plus signs now? Well, yes. Plus, plus, and plus, we're adding everything. How many terms do we have? Well, if we have 3 plus signs, we must have 4 terms, so negative 5, negative 1x, 7, and 8x. So here are our terms, negative 5, we have negative 1x, we have positive 7, and then we have a positive 8x. Okay, those are all our terms. Now, which ones are like each other? Well, it looks like this negative 1x and positive 8x, they're like each other because they both have x. So negative 1x, and then we have positive 8x. Go ahead and write those. What else are like each other? Well, it looks like this negative 5 and positive 7. Those are constants, so we go ahead and write those. Those are like each other. They're just normal numbers. Now for coefficients, we have negative 1 and positive 8. Those are the numbers that are multiplying by the variables. And then what are our constants? Well, our constants here are going to be just the regular numbers, negative 5 and 7. So negative 5 and 7. Okay, they constantly are negative 5 and constantly 7. Those values don't change. And then let's go ahead and simplify this and combine our like terms. So negative 1x plus 8x, negative 1 plus 8, you add their coefficients. That's going to be 7, positive 7. So it's going to be 7x. And then if you take this negative 5 and positive 7, add those together, you're going to get positive 2. So we can go ahead and write plus 2. Okay, so this would be our simplified expression. On to number 5, we have this expression of negative 14 plus x. Don't forget that is going to be, there's an invisible 1 in front here, so you should just go ahead and write that now. Negative 14 plus 1x plus 8, but then it's minus 7x. So we like the plus sign here, we like this plus sign. For this minus sign, let's go ahead and change that. So we have negative 14 first, we have plus 1x, we have plus 8, and instead of saying subtracting 7x, we can write adding a negative 7x, because adding the opposite, or keep change flip, is going to get us the same value. All right, so do we have all plus signs here? We have plus, plus, and plus, so 3 plus signs, so we must have 4 terms. So 1, 2, 3, and 4 terms. So negative 14 is the first one, positive 1x is the second one, positive 8 is the third, and negative 7x is the fourth term. Now, which ones are like each other? Well, let's start with the x's. We have 1x and negative 7x, so positive 1x, negative 7x, those are like each other. And what else do we have here? Well, it looks like we have 2 constants of negative 14 and positive 8, so negative 14 and positive 8. Now our coefficients are the numbers that are multiplying by the variable, so 1 and negative 7, so we go ahead and write our coefficients. 1, positive 1, negative 7. Our constants are just these normal integers over here. So we have our negative 14 and positive 8. Now to simplify our expression, let's combine our like terms or add our like terms together. So 1x plus negative 7x, if we add these together, 1 plus negative 7, if we add their coefficients, that's negative 6. So it's going to be negative 6x. And then if we go ahead and add our constant terms here, negative 14 plus 8, negative 14 plus 8 is going to be negative 6. So we're going to go ahead and add a negative 6 here. Okay, now this is almost done. We can go ahead and simplify this just a little bit because there are 2 symbols here. Remember, we can turn subtraction problems into addition problems. We can also turn addition problems into subtraction problems. So if we keep this and then we change the addition to subtraction, and the opposite of negative 6 is going to be a positive 6. So negative 6x minus 6 would be a more simplified way of writing this expression. All right, for number 6, we have this expression of negative 9x plus 5 minus 4x minus 12. It looks like we have an addition sign here, which we like. However, this subtraction and this subtraction, we want to go ahead and rewrite as addition here. So we can write this as negative 9x, keep that the same, add the 5, keep that the same. But instead of subtracting 4x, we can say we're adding a negative 4x, okay? And instead of saying subtracting 12, we can say let's add a negative 12. Okay, so that's going to be the same type of expression here, but this time we have all plus signs, 1, 2, and 3 plus signs. And so we have 4 terms. We have negative 9x, 5, negative 4x, and negative 12. So here are our terms here. Okay, so out of these different 4 terms, which ones are like each other? Well, there's negative 9x and negative 4x. Those are like terms. So negative 9x and negative 4x. Okay, I'm going to put a big slash here to separate these with the others. And then we have our constant terms here of 5 and negative 12. So we have 5 and negative 12. Those are our constants. Okay, our coefficients here are going to be negative 9 and negative 4. They're multiplying by our variables. And then what are our constants here? Well, our constant terms, that's 5 and negative 12. So we can go to write 5 and negative 12. And if we go ahead and combine our like terms, we have a negative 9x and negative 4x. If you add negative 9 and negative 4, you're going to get negative 13x. And then if you add 5 and negative 12 together, you're going to get negative 7. So we're going to write plus and then a negative 7. Are we done? Well, not quite. We can simplify this just a little bit more. So just like the last example, if we're adding a negative, we can also subtract a positive. So keep this, and then let's change the addition to subtraction, and the opposite of negative 7 is positive 7. So this would be the most simplified version for this expression. Here's number 7. So notice how we changed variables here from x to y, but it still works the same. We have this expression of 3y minus 7 plus 2y plus 10. We like this plus sign and this plus sign. It's this minus sign we'd like to maybe rewrite over here. So instead of saying 3y minus 7, we can say 3y plus a negative 7. Okay, same thing, and then plus 2y, and then plus 10 afterwards. So it looks like we have a plus sign, and a plus sign. And so we have 1, 2, 3, and 4 terms. So our terms are 3y, negative 7, positive 2y, and a positive 10. So we have these 4 terms, but which ones are like each other? This 3y and 2y, those ones are like each other. They both have the variable y. And then we can go ahead and say, well, what else are like each other? Well, we have this negative 7 and 10. Those are our constants, so negative 7 and 10. Our coefficients here are going to be this 3 and 2, since they're multiplying by the variable y. And then our constant terms here of negative 7 and 10, those are our constants. They're just regular numbers. In this case, they're integers. And then for simplifying this, 3y plus 2y, 3 plus 2, adding their coefficients is going to be 5y. And then negative 7 plus 10 is going to be a positive 3, so we can go ahead and write plus 3. And that is as simplified as we can write this answer, or this algebraic expression. For number 8, we have this expression of negative 3 minus 5y plus 6 minus 4y. So right off the bat, we like this plus sign. Let's go ahead and rewrite this minus and this minus over here. So we have negative 3. Instead of writing minus 5y, we can write plus the opposite of 5y, which is negative 5y. And then we have a plus 6. And instead of saying minus 4y, we can write plus a negative 4y. Okay, so what are our terms here? We have plus, plus, and plus. So now that we have all plus signs, we can see we have terms, we have 4 of them that are separated by the plus sign. So we have negative 3, negative 5y, positive 6, and negative 4y. Those are our terms. Now, which ones are like each other? Well, this negative 5y and negative 4y, those are like each other. And what else are like each other here? Well, it looks like we have a negative 3 and a positive 6. So we can write negative 3 and positive 6. For our coefficients, we have negative 5 and negative 4. Let's go ahead and write negative 5 and negative 4. Those are our coefficients. And then for our constants, we have negative 3 and 6. So simplifying this, we can combine like terms. So negative 5y added to negative 4y. If we add negative 5 and negative 4, their coefficients, we get negative 9y. And then if we add these constant terms, negative 3 plus 6, that's going to be a positive 3. This is our simplified expression. Here's number 9. For number 9, we have this expression of 2y minus 9 minus 3y plus 4. So we like this plus sign here, but let's go ahead and rearrange and rewrite these minus signs here. So instead of saying 2y minus 9, we can say 2y plus a negative 9. Adding the opposite. Instead of saying minus 3y, we can write plus a negative 3y. Okay, and then we have a plus 4 at the end here. So we just rewrote this as a sum by keeping, changing, and flipping to the opposite. Or remember, instead of subtracting a value, we can add its opposite. Okay, another way of thinking about it. It looks like we have 1, 2, 3, 4 terms. So there's always one more term than the number of plus signs. So we have 2y, negative 9, negative 3y, don't forget those negatives, and then we have a positive 4. Now, which ones are like each other? Well, 2y and negative 3y, 2y and negative 3y, those are like each other. And besides that, it looks like we have a negative 9 and positive 4. Negative 9 and positive 4, those are like terms as well. Now our coefficients here are 2 and negative 3, so positive 2 and negative 3, those are our coefficients. And then our constants are negative 9 and positive 4. Simplifying this, this 2y plus negative 3y, 2 plus negative 3 is negative 1, so you can write negative 1y here. And then this negative 9 plus 4, that's going to be negative 5, right? So we can add here a negative 5. Okay, now a couple things we can simplify here. Well, keep in mind that 1 times anything by the identity property of multiplication means we don't have to write the 1, so we can write negative y. And instead of saying adding a negative, we can also say subtracting a positive. So we can subtract a positive 5 if we keep change and flip, or we turn an addition problem into a subtraction problem. Here's number 10. For number 10, we have this expression of negative 8y minus 9 plus 10 minus 5y. So we like this plus sign. However, this minus and minus, let's go ahead and rewrite those. So we have negative 8y. Instead of subtracting 9, we can write plus a negative 9. We have a plus 10, which is fine. And instead of saying minus 5y, we can say plus a negative 5y. All right, at this point we have a plus, and another plus. So it looks like we have 1, 2, 3, and 4 different terms. So negative 8y is the first one, negative 9 is the second term, positive 10 is the third term, and negative 5y is that fourth term. Okay, so which ones are like each other? Negative 8y and negative 5y, those are like each other. They both have y. And besides that, it looks like we also have this negative 9 and positive 10. Those are constants, or they're also like terms. And so our coefficients here are negative 8 and negative 5. Those numbers multiplying by y. And then let's go ahead and write our constants. That's this negative 9 and positive 10. Now, if we try to simplify this, we can combine our like terms, add these ones that are like each other. So negative 8y plus negative 5y, we can add their coefficients together. So negative 8 plus negative 5 is negative 13. Okay, so it's negative 13y. And then if we have this negative 9 plus 10, that's equal to positive 1. So we go ahead and write plus 1. This is as simplified as we could write this expression. For number 11, we have this negative 4y plus 9 plus 4y minus 15. We almost had all plus signs, but we have to do a little bit of work here. So we like these, but instead of writing minus 15, we can add the opposite. So negative 4y plus 9 plus 4y plus a negative 15. Right, if we add the opposite or keep change and flip it to the opposite. So we have a plus, and a plus here. So we have 4 terms, 1, 2, 3, and 4. So negative 4y is our first one, positive 9 is our second one, 4y is our third one, and negative 15 is our fourth one. Now, which ones are like each other? This negative 4y and positive 4y are like each other. So we're going to have negative 4y and positive 4y. And besides those, we have over here this positive 9 and negative 15. So positive 9, negative 15. Now our coefficients here are negative 4 and positive 4. That's kind of interesting, right? Because our coefficients are actually opposites. They have the same absolute value. And for our constants here, we have 9 and negative 15. So 9 and negative 15. If you go ahead and simplify this, we can go ahead and add the like terms together. So negative 4y plus 4y. If you add their coefficients, we actually get 0, right? Because they're opposites. So negative 4y plus 4y is going to technically be 0y. I'll go ahead and write that right now for just a moment. And then if we go ahead and add this 9 plus negative 15, that's going to equal negative 6. So we have plus a negative 6 here. Right now, since negative 4y plus 4y, they're opposites, they add to get 0y, so we actually don't write 0y. And then instead of writing this plus a negative 6, that's really the same thing as minus 6. So we can just actually have a final answer here of negative 6. Again, 0 times y, or 0 times anything, is going to be 0. Or you can say that if you add these opposites, you just get 0, right? That's also another way to think about that. All right, here's one final expression. So for number 12, we have negative 8 minus 3y plus 8 plus y, and plus another y here. So do we see some plus signs? Yes, we like this 1, 2, 3, 4. We have 4 plus signs, but we have 1 minus sign. So make sure we know what this represents. This is negative 8. And instead of writing minus 3y, we can write plus a negative 3y. Okay, that's going to be equivalent or the same. Then we have plus 8. And then I want to make sure we understand that there is an invisible 1 in front of each of these y's, right? Because there's 1 of each of them. So we have plus 1y, plus 1y, and plus 1 more y. Okay, so how many plus signs do we have? 1, 2, 3, and 4, and 5 plus signs. So there must be 6 terms, right? So 1, 2, 3, 4, 5, and 6. So our terms here, let's go ahead and write them. We have negative 8, we have negative 3y, we have a positive 8, we have a positive 1y, another positive 1y, and another positive 1y. All right, so which ones are like each other? Well, all the y's are like each other. So this one, this one, this one, and this one. So we have negative 3y, positive 1y, positive 1y, and another positive 1y. And do we have any other like terms? Well, yeah, we have this negative 8 and positive 8. So we can write negative 8 and positive 8. Those are like each other. Now, what are our coefficients? Well, we have negative 3, 1, 1, and 1. So negative 3, positive 1, positive 1, and positive 1. Those are our coefficients. For our constants, constant terms, negative 8 and positive 8, negative 8 and positive 8. Let's go ahead and simplify this. So let's combine these. So we can add all of these together. So 1 plus 1 plus 1 would be 3, and a negative 3 plus 3 would be 0. So kind of like the last example, we're actually going to have no y's left over. And then this negative 8 plus 8, those are opposites. That's actually going to add on 0. So we can go ahead and write plus 0. So 0 times something plus 0 means this whole thing is just going to be 0, right? So it doesn't matter what the value for y would be. No matter what it is, the whole expression is always going to equal 0. All right, so there you have 12 different practice problems dealing with algebraic expressions. Hopefully, if you practiced all of these and you really took your time to think about it, that you now feel more comfortable with how to identify each of these vocab words and what each of the parts of these expressions mean and what they represent and how to simplify them. So if you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing, and I'll see you in the next one.